So we're just playing with cables up here for a minute. You can talk among yourselves for a while. It's just for now, but I'll try and find somebody else. Whatever you first find. There's a link on the agenda page.
Surely it's more.
Yeah, whatever you want to use.
I thought about it. Probably all these things.
Thank you. Thanks for doing it.
It's important.
That's
You want to try mine? Just, I guess it won't make any difference if we try and see. Yeah. You never know. You kind of tweak it just right.
I think that the word you should ask yourself is whether it's space. I hate to take minutes, but I'm perfectly happy to have what do you want me to do? In Etherpad? All right, I will go and pull it on my screen. Okay.
Blue screen. Do you need?
Somebody's going to get another cable.
Okay, great.
Maybe I was looking for this.
He's a lawyer.
Steven,
Yep.
pulled out my Metro pass yesterday to take Metro. I discovered my Irish regime SIM card. My SIM card. But I never see it refilled. It's like shit. I call it after the minutes I found that Scotch tape that I used to take the other thing. I turned around and taped itself to my different part. I'm like, oh, okay. So, since after I really, find that will sell me a SIM card and let me refill it online with a credit card. I'm happy. So I wound up with Irish free. Right, which seems to apparently satisfy everything, except that it turns out that when you type in the credit card number.
So I guess we could, if it doesn't get fixed quick, we could switch over to the Meet Echo screen. Give it another minute.
It's not obvious. You got to actually trying to
we could just take that HDMI, put it here. So let's see if this does the magic. Yeah.
try.
So I guess if that doesn't work for some reason, we could use the Meet Echo screen for this, right? Okay, so
By the company, by the credit card company. Oh, that sounds like really
so you can see the red button anyway, right? So it's moved.
It's probably a DRM failure. HDCP, you know. Yeah, I'm half serious, but all of us really don't like DRM. I'm accommodating the fact that we accept diversity.
It's just mirroring there anyway.
We still laugh at you, but we accept that you're diversity. You have stupid ideas. You are not stupid. You have stupid ideas. Unless you lie about wow, I can totally delete that cable. That thread.
It was working when we come in the room, yeah, but then it stops. I guess we could switch over to the Meet Echo one.
I suppose I read enough. Don't show any passwords for sure.
Okay.
That's bad.
Is that one long enough to come over here?
Sorry, just a second here. I just realized that this one being broadcast is a specific message to me.
This one is the direct one that goes there. It's for a separate thing. That one is for the
So can we project from
actually, we need this because we have remote presenters there. So
we don't have any remote presenter system.
And can I serialize CDBL to JSON then? Yes, I can now serialize CDBL to JSON. But I can't. It's not. It is the signal. I will decode any package.
Off and on again.
It doesn't need anything below it, right? It just levitate, you know, stack, you know,
What should be
at
something
layer
very
5,
special?
just levitate right to your ship. And the layers below it just take care of themselves.
Easy as this.
Yeah.
There you go. And don't know why we started.
All right, thank you.
Thank you.
Hi, Al.
Okay.
Good. So the technic. Oh, may I have your attention, please? Okay. So the technical problem was solved by turning it off, then on again. Right. Okay. So welcome to the Lake BOF, lightweight AIC for IoT. We do know that using the words like lightweight or simple for protocols gets you in the future a 400-page document, but we're risking it anyway. So this is the Notewell. You've seen it at least once since the start of this week. And here's the agenda. So the obvious administrivia and history that we'll do. The blue sheets are going around, and we do have a JabberScribe and a minute taker. We'll then go through a requirement presentation, and then two short presentations about the proposed solutions. After that, we'll see the proposed charter and have the charter discussion and the usual BOF questions. After which we can either talk more about the charter or more about the requirements. So, any agenda bashing? No, good. So, about the process. Well, there hasn't been any decision made. The ISG has not decided to set up a new working group. If they had, they would just set it up. Above comes to answer the questions about whether the community is ready for a working group. So it's not a foregone conclusion. And the most important output of this meeting is whether we are recommending to the ISG, because ultimately it's their decision, to form a working group or not. So if the answer is yes, and then we have still not decided on the solution, and we still haven't decided on the requirements. There is a requirements draft, there is a requirement presentation, but the requirements are not final. They are still up in the air, and so we can add requirements, remove requirements, dispense with them entirely and do something else. Anything goes. So a good output from this is a recommendation on whether to set up or not set up a working group, and as much as we can about the requirements, although they will not be final requirements, are usually part of the deliverables of a working group. So this is sort of a timeline of how long we've been doing this. Quite a while. Yep. Wow.
So just as a check, because there's been a bunch of discussion about this on Sec Dispatch, there was this virtual interim meeting that went into this in detail. How many people would think themselves as pretty familiar with this particular topic? Okay, so that's like maybe more than 50% of the room. How many people how many people are there for whom this is a totally new thing? Only a few. Okay, so I guess for the presenters, then you don't need to kind of go through excruciating background for most of the room, I think. But if you're in the room and you haven't been familiar with this before, then you know, let us know and ask the presenters clarifying questions if needed. Sorry.
Okay, cool. So in that case, we're going for the presentations. And we're starting with the requirements. Goran?
So just whilst an AD goes to the mic, we wanted to just have clarifying questions for these three presentation slots, and then have the discussion after those have happened. Because again, most of you are familiar with a lot of this, so you hopefully don't need to do too much clarifying.
Thank you. Okay, hello everybody. Can you hear me? Great. Okay, so I'm Göran Selander, and I'm going to talk about requirements for lightweight key exchange protocol for OSCORE. So basically, if you read the charter proposal, which is the outcome of the discussion in Sec Dispatch, the lake is about specifying a lightweight authenticated key exchange protocol for OSCORE, which recently has become an RFC. And the requirements are therefore based on the conditions for how OSCORE is being deployed in constrained environments.
Sorry, Goran, just to clarify, I mean, so this is Goran's view of the requirements going into the BOF. It's not that these are the formal agreed requirements by everybody ahead of time.
Right.
Yeah.
But this was a security AD summary of the discussion in Sec Dispatch, as you could see from the charter yourself.
Yeah.
So have a look. We'll come to the charter. That's not the end of the presentations. And this is not a new subject in the IETF. It's been on the agenda since 2016, I think, and extensively discussed during the spring with a virtual interim dedicated to this topic. And after this virtual interim, I was asked to compile the requirements summarizing the discussion, and I did that, and I got some more comments, and I updated that, and that's the version we are going through in this slide set. Right, so first a couple of slides on OSCORE, if you're not familiar with that. So OSCORE is a communication security protocol for co-op, and it's basically intended to protect what's called the co-op request response layer, which is the upper sublayer of co-op. And people, so you can think about it like a REST layer, and including things like protecting payload, URI path, and code. And it doesn't protect things like the messaging sublayer, the lower sublayer of co-op, which is the binding to UDP. And therefore, it's suitable for, it's easy to change transport protocol without changing the protection of the actual REST message. So that's also inherently provides some features where you could introduce proxies, and proxies could make changes to these headers which are not protected, which enables forwarding and stateless proxies and other good functions for IoT deployments. OSCORE was initially designed for both unicast and multicast. And that has turned out to be an interesting feature from an industry point of view, like the lighting industry, who think this is a good idea that you could protect multicasts over co-op communication. So many deployments are expected to have both unicast and multicast functionality. It's defined in terms of IoT primitives such as co-op, CBOR, and COSI. And that makes it suitable for lightweight deployments. And it also has a low message overhead. So OSCORE is now an RFC, but there is not an AKE which could be used for providing peer-to-peer forward secrecy. And so for peer-to-peer deployments to get forward secrecy, and also for getting public key-based authentication between peers. So that's just a background. And here are some examples over here where OSCORE is being used, applied, a number of IETF working groups, and also other IoT forums are either specifying its use or referencing it, or has shown an interest to deploy OSCORE. And on the right, you see a number of development and testing activities, which includes things like the hackathon activities. The multicast was tested the day before yesterday in interop test, a number of open source projects, and other things going on. Okay, so now we go to the requirements. So obviously, if you're going to be in a key exchange protocol for OSCORE, you need to provide the input and be transported as OSCORE. So OSCORE needs a master secret that's used for deriving the encryption keys. And this master secret should have the good properties, perfect forward secrecy, a good amount of randomness. OSCORE also needs to have sender IDs, which are peer identifiers, and they need to be should be able to be arbitrarily short because they're sent in each message. And we also need COSI algorithms, which is the encryption and HKDF algorithms used by OSCORE. Okay, next is authentication credentials. And since there are various different kinds of IoT deployments, we need both to have symmetric and asymmetric. And certain deployments are only pre-shared. So you have provisioning and pre-shared keys, so that's important. And raw public keys also have a natural role in IoT deployments when you don't want to send certificates. There are additional credentials requirements being discussed on the mailing list. I didn't, we haven't completed on that, but basically that's, I noted that here as an indication that requirements discussion is still ongoing.
I just wanted to sharpen this point about raw public keys. My understanding was that when you say raw public keys, you also mean a short identifier which refers to a public key as opposed to carrying the public key in band $7250, right?
Yes, I mean basically there are different ways of identifying. That's not really covered by the requirement. It's sort of the fact that you can use a public key which is not certified in itself. Does that answer the question?
I mean, sort of, but you can imagine a protocol which only carried the keys in band and was not able to refer to them externally, and it's a different set of requirements, somewhat different set of requirements if you have to refer to them externally. It's not trivial. It's not trivial. Doesn't fall trivially.
So I didn't really understand. Could you please expand?
Sure. So some of the proposals I've seen involve having very short public key identifiers in the space on the order of a byte or two, right? And
sorry, could you speak a little slower?
Some of the designs I've seen involve having very short public key identifiers in the order of a byte or two, and then the public key is then carried externally, right?
Right.
And so that's a different protocol requirement from being able to carry raw public keys in the protocol, and actually has some somewhat different design constraints. So I just want to make sure that we get that on the table if that's a requirement.
I'm sorry, I really have a hard time understanding you, but I think perhaps, I'm sorry, Eric.
Okay, so this is Ben Kadek, trying to channel Eckert.
Thank you.
So you have on the slide raw public key, and it sounds like you're using raw public key to just mean, the material that the two sides have to agree upon is literally the raw public key, and there's no external certification or trust anchor or anything like that. And Eric is trying to ask about how you translate to the bits on the wire, whether you are going to say, I have a raw public key and I'm always sending the full, however many octets of public key, or if you might also want to consider a case where the two parties have some sort of out-of-band database to say, I'm going to send you the octet 5, and you secretly know that matches to the 32 octet.
Right. Okay, that was the key identifier part, I suppose. Yeah, okay. So, yes, I mean, the point is that there are both these type of deployments. So I don't see any problem to, both are requirements. Okay. Then we have the crypto agility part. These are things which are built into infrastructure and long lifetimes. So you need to be able to support change of algorithms, or having multiple algorithms and securely negotiate them. So that goes both with the score algorithms and with the AKE algorithms. And then we come to the lightweight part, which is what's been discussed most. So what we mean by lightweight is that it should be low in resource consumption as measured by bytes on the wire, wall clock time to complete, so from starting the protocol to the end, power consumption, and amount of new code required on an end system which already has an OS-core stack. Basically, this is also the formulation coming out of the SEC dispatch discussion. And some of these are easy to quantify, whereas others are more difficult to quantify. And that's basically what this lightweight discussion has been about. So how do we quantify this? How do we compare two protocols and say this is a better protocol? So bytes on the wire is fairly straightforward if you look at the message sizes of the protocol. Byte on the wire is also important because, as we shall see in the benchmarks coming after this slide, it impacts time to complete and it impacts power consumption. Wall clock time can also be translated into protocol requirements, like looking at round trips. So as few round trips as possible is sort of a consequence of this, of L1 here, which means that we are in practice, looking for a one round-trip protocol which is mutually authenticated, so we need to have at least 3 messages. Power consumption is one thing that depends a lot on the circumstances of the deployment. So in particular, radio technology. So there's one of the benchmarks is looking at that. And finally, the indication of the code complexity aspect is based on how a given OSCORE implementation can be reused in terms of code. So these are very general statements, and we were requested specifically during the SEC dispatch process to come with concrete, measurable benchmarks. And there were 3 benchmarks presented, and they were designed by experts on these technologies. And these 3 are specifically relevant to OSCORE. That's why they were selected. So narrowband IoT, LoRaWAN, and 6-dish. And each of them are using input based on message sizes, which is specified in an LWIG draft. And the task of comparing security protocols was also a task that was given to us during this long period. So that's important that when we are comparing protocols, we actually make the same assumptions. So here's the first benchmark. It's looking at narrowband IoT energy consumption. Narrowband IoT is a licensed spectrum with low data rates. So as a consequence of being licensed, the device is allowed to have a high transmit power. And the consequence of low data rates in combination with this means that there is a high per byte energy consumption. So the benchmark we're looking at is the energy consumption of the key exchange based on the computational model used in the 3GPP when they design these type of radio technologies. And here is just one example of a table. And the general conclusion looking at this benchmark and this spreadsheet is that the higher message overhead results in higher energy consumption. This is a very clear correlation, and it doesn't come to surprise to many. So the requirement here is the AKE should have as few bytes as reasonably possible. And there was a discussion what is reasonably possible. This is not a strict engineering requirement, but it's a clear indication that message size matter. So that's why we're focusing a lot on the message sizes. Second benchmark looked at LoRaWAN, backoff times. So in contrast to the previous, this is unlicensed radio, and therefore there is regulations for how much you could use a certain frequency band. So there you need to make a backoff period after transmission. This is called the duty cycle, and the benchmark here is looking at the European setting with 1% duty cycle and also associated data rates. So the benchmark here is what is the overall wall clock completion time for a key exchange protocol using a packet size of 51 bytes, which is a very common used data rate. Some networks only support that type of data rates. And the conclusion again is that there's a high penalty for having large messages, and this is then caused by the need for fragmentation and having to wait between these packets. So the AKE should fit in as few packets as possible. That's basically that's the second requirement, second benchmark. And then we have the third one, which is looking at 6-dish, and this is similar to the previous. So whereas in narrowband IoT is more like a linear function of of message size. This is more like a stepwise function where the number of frames needed is determining the behavior of the so the performance of the key exchange. So in this case, we're looking at a network join formation procedure when many devices at the same time are doing a key exchange protocol to connect to a central unit. And these different devices, their protocol messages are fragmented, and these fragments may collide with each other, leading to retransmission and causing long network formation times. So the benchmark here is to look at the number of frames needed for the key exchange message, and the requirement is to make them as few frames as possible. And here we noted when we went through the slides that there was an error in the interim slides. So basically we didn't really follow this formula, uplink downlink formula, which led to a statement about a factor 3 instead of a factor 2.6 between the different compared protocols here. So it's, I mean, the main conclusion remains the same, that as few frames as possible is giving this the optimal performance. These numbers were taken from a production network, 60s production network. And yeah, and also all these three benchmarks were done by people who are experts in this field. So that comes to the last slide of the requirements presentation, summarizing it in that the AKE shall support pre-shared key, raw public key, certificate-based authentication, negotiation of algorithms, both OSCORE and AKE, support the same transport and OSCORE. The protocol, after protocol run, the peers should agree on these parameters that OSCORE is using, and it shall reuse CBOR, CoAP, and COSI for load complexity, and be 3-pass, 1 round trip, as small as reasonably achievable to fit into lower round buckets, and 6-ish frames, and then we have this new requirement.
Okay, before we start the mic line, I'd just like to remind that we're talking about clarifying questions. If you think one of these requirements is bogus, that's fine, but don't talk about this now. We'll have time for that later.
Bob Moskowitz, agency consulting. Have you considered as a requirement or not a requirement the number of operations, number of times that Blake will be run in the lifetime of device? Thus, what sort of entropy or other things may be appropriate for the keys and impacting key size and the rest? So is this something like a lifetime device that this only gets done 100 times in the lifetime device, or this something which, no, we have 100,000 times in lifetime devices becomes important, so we have to concern ourselves with this sort of an issue?
So again, Bob, asking is there a different requirement or a clarifying thing? Which slide does that refer to?
This one.
And what's unclear on this slide that you're asking about?
Oh, well, something could be in there or not.
No, I mean, I think it's a fine question, but we really want to do clarifying, get the other presentations out of the way, and then have this discussion.
David Black, 2 questions. First, which is clearly clarifying, second, which probably is. First question, third requirement says good amount of randomness. What does that mean?
Sorry, there's something wrong with my ears. So that could
okay, sorry.
Or maybe
third bullet says, second line, quote, good amount of randomness. What does that mean?
Right. So, I mean, people like to use the word entropy, but entropy has a very precise meaning. And so this phrase is actually quoted from another RFC. So
I'm more interested in putting a number behind good amount. I don't care whether you call it randomness, entropy, Fred, or George. What is the actual requirement that has to happen?
So again, this is a presentation about requirements. I don't think there's a lack of clarity here.
So I mean, so the point is that this is not saying 128 bits. That's not on the level. Is that what you wanted to have?
No.
No. So what?
I want to understand ballpark. So suppose, are we talking 128, 112, 96, 64, 32? Which one of those numbers?
That's not on this level. That's not on this level. That should be. I mean, you should be able to set that. And any of those are fine. I mean, that's as you decide from the application point of view.
Okay. And another question: are you assuming that the PSK is a strong secret, i.e., you don't have to strengthen to defend against somebody who used the password?
Yes, that should be clarified. So okay. The point is, it needs to have. Yeah, this formulation, a good amount of randomness, is a quote from I think HKDF, but it might be some other RFC. Okay, and the purpose of this is to not get into this discussion. But basically, what we're doing, we take the key and then we use HKDF both in expand and the other mode, and then we use it. So it doesn't have to be uniform, but it needs to have it.
Okay, got it. So
there will be a requirement.
Good amount of randomness out. And whatever the randomness is depends on how protocol is being used. Okay, thank you.
Thanks.
So Hannes, try hard.
I obviously just don't sometimes succeed. I think the requirements miss the privacy aspects, because in the previous comparison between ad hoc and DTLS, it should be noted they are providing different privacy properties, and of course they come at a cost. If we strip out the privacy features of DTLS, then it will reduce the size, but that's an important decision on whether you want those or not.
Sure, that's a fine comment. That was not a clarifying question.
No, and it's not. I don't think it's correct, Hans.
So again, Goran, let's just get the clarifying question out of the way and keep the discussion to later.
I can't reiterate enough the ground rules we try to set, which is clarifying comments only. We will have a time to actually provide kind of feedback, so please let us run the process so we can finish the materials and have the conversation.
So I have
your name?
René Struik. I don't really understand the background of the 3-pass remark, but maybe that's ruled out of order. But I have a more general question: is shouldn't, if we really want to design another protocol, you consider the problem a little bit broader? If you look at some of the application spaces, they don't just have an authenticated key agreement protocol. There are at least 50 RFCs all dealing with kind of protocol variations using BRS, KI, and there's some big selection protocol at the selection process at CFRG. There's some EST protocols. Should you look at also more broadly at what does it take a small device to get on the network and to be...
So my count is that we have had 0 clarifying questions.
I would like to finish before being interrupted, but I think isn't it a legitimate question to consider this topic a little bit more broadly, because otherwise we're optimizing on one aspect and killing it on other aspects.
I think there are many things that you can expand on in these requirements. The problem we're having right now is that people are deploying on SCORE without perfect forward secrecy. And we think that we need to have a fix for that. We like to be able to also use public key authentication. That doesn't exclude that there are other ways of doing this, but we need to have one solution and not wait another 3 years for this to happen. So that's my high-level answer to that.
Okay, we can look for another point solution.
So again, I mean, these questions are all welcome, but they really weren't clarifying. So Goran, given the number of people in the room who are familiar with this, can we speed up a little bit, please?
I'm done.
On the next presentation, I mean.
On the next presentation, yeah, sure. Am I taking it right now, or? Okay.
Yeah.
Should I do it? Yeah. Okay. So let's speed up. This was intended to be an overview as well. I'm sorry for making many slides. This is ad hoc version 13, and I just want to talk a little bit about how it matches the requirements. We can probably, we could probably skip a lot of this. It's a Sigma IBAS protocol. It uses CBOR sequences of zebra elements, and COSI constructs like encrypt and sign. Symmetric and asymmetric versions are very similar. So how is this suitable for OSCORE? We have the connection identifiers providing the OSCORE sender IDs. We have a very simple negotiation of cipher suites, which supports negotiation of COSI algorithms. And we're using the same COSI algorithms and IANA registries as OSCORE and group OSCORE. And it's a really small footprint because it reuses CBOR COSI and different COSI constructs. Another constraint features of this protocol is that it supports, it's a little bit related to Eric's question about how we identify different public keys. So you may identify with a COSI key ID or these very nice things coming out of COSI, the X5T, X5U, X5 chain, and X5 bag. And also the certificates need not be transported in the message. So security-wise, there's been a special part of the interim discussion on this. So I think I should leave it out, but the main security properties comes from being sigma I, and then there are some other good features. This has been reviewed since 2016, but there are lately more advanced reviews. There's a formal verification on ProVerif. There's another one on Tamarin ongoing, and there were 2 crypto panel reviews available. And the latter one of them provides a good overview of the protocol. And all review comments have been addressed. So I just want to go to this, is my last slide, that ad hoc actually matches the requirements, and it performs well in these benchmarks. So there are, it's a little bit constructed image here, but these are comparing pre-shared keys, PSK, ECDHE, and raw public keys, using the 3 benchmarks, B1, B2, B3 in the previous presentation. So first you see the number, B1 you see the number of bytes, so taking the PSK first. B2 is the number of packets. That was, if you remember, the number of LoRaWAN packets that you need to send to complete the protocol. And that's actually 1 message per packet, so that's optimal. And B3 was the number of 60 frames that you need to complete the protocol, and that's also 1 message per frame. So that was a PSK case. Now for the raw public key case, as you see from the B1 column, there are not all messages fit into the packets and the frames. So we need to have multiple packets and frames. But if you compare with taking sort of a sigma I skeleton top at the bottom right, and you take sort of common crypto object sizes using the ephemeral key, the signature, and the MAC. And that's how so it's like sending only these crypto objects in the messages. You get certain message sizes. And if you see how many packets and frames that correspond to, those are exactly the same as with ad hoc. So it's in that sense optimal from the point of view of number of packets and frames. So that's my last slide. Yeah, that's basically it. Thanks.
So, go on, ask a clarifying question. No, no, great, thank you. I guess Eric.
X. Do we not have a box? It's not a box.
It's an X now, is it?
Yeah, it's like that. Does that work? Yeah. So I guess, we were asked to come and talk about some multiple points in the design space. So here's another point in the design space. The underlying rationale for this is we spent an enormous amount of time developing TLS 1.3. and we're already seeing like enormous on implementation and academic interest. I have some stuff here. And so here's a fully general protocol, right? And so and we're already seeing a lot of work on extensions and things like subsource and ESNI and stuff like that. And so it'd be great to be able to like have something where you could like leverage the ongoing work and have a line of protocols that continues to enhance as like the sort of large massive work that already is going on in TLS continues to go on. But as Joran some slides so nicely showed, it's not what you'd call compact. So the interesting question is, can you continue to benefit from like all that line of work and the continuous lines of improvement and patching, but also have a compact protocol? So that's the problem like that Richard and I sort of set out to work on. There are sort of two general approaches one can kind of take here. One you could call like cutting fat, and one you could call compression. So the cutting fat one is like pretty straightforward. Change hands. So keep the protocol like fully general, but just cut like all the encoding overhead that was in the bespoke sort of TLS protocol encoding that like no one ever bothered to optimize because it just was not like a major thing. As sort of reference point, like if you're working on the web, like the vast majority of the data on like TLS handshakes on the web is like the certificates. And so just nobody cares about like, an extra 20 bytes here or there on the protocol because the certificate is the big thing. And especially like in Quick, where you actually have to pad things out to like 1200 bytes anyway. So there's like a lot of sort of pile of extra stuff that like arguably is good, arguably is bad, but is there because of encoding. So there's like a lot of places where they're running length fields. So you'll have like, it'll be like, well, here's like something which is a length, and then like here's the length of the vector. That's the only thing in that thing. And so like, wait a second, I could have like just figured that out without working from that. There's a lot of places where there are fixed length fields that like actually have like sizes that are dramatically too large for the thing that goes in them. So it's like very common to see like 24 byte field for 24 bit a length field for something like essentially is never ever larger than 65 kilobytes. And so basically you can do things like go to variable length integers where you get much better encodings. There's a number of places where there are like values that are basic or implicit, some particular redundancy between named groups and key shares, and then you can actually remove. There's a couple places where we can shorten like some excessively long crypto variables, like does the random value actually need to be 32 octets? There's like we're kind of using that for anti-downgrade, but if you have a system where you don't have downgrade problems, it's an issue. So effectively, this gets you like a TLS 1.3 that is like a direct one-to-one correspondent with TLS 1.3, which is like tighter encoding. You could also imagine like using CBOR or something like that, but this is like one option. The sort of other option that we also explored is basically do a lot more of nailing things down and remove negotiation for things you didn't have to negotiate. And the idea here is you probably have some kind of explicit shape parameter that said, this is like one of the 18 profiles that I have that I'm willing to negotiate. And if you're with that kind of stuff, you can do extraordinarily large amounts of compression, basically by like essentially saying, well, look, I don't need length fields because I know exactly what I'm doing here. And so if you do that, then you can actually get quite a bit more compression. There's been some discussion about how to do this mechanically. There's basically two options. One is to treat, in both these cases actually, one is to sort of treat the wire transcript as the transcript you sign over, and the other is to reconstruct the original TLS 1.3 transcript and sign over that. So there's advantages in both designs. Scott, go ahead.
Quick question, does option 2 maintain the crypto agility? That was one of the requirements?
Largely yes, depending on exactly how you cut things up. So in particular, so one thing that you might or might not think you needed to do was not know in advance whether you were going to do raw public keys or PSK. So if you know in advance, you wouldn't have to negotiate that, right? There's been a bunch of back and forth between Richard and I and Karthik Bhagavan about whether it makes more sense to re-expand the transcript or not. The advantage of re-expanding the transcript is like then the proofs carry over as long as you can demonstrate isomorphism on the compression. Of course, you need a cross-protocol defense in that case. We're working with Karthik, and we think that either approach of these has a pretty reasonable chance of keeping the TLS 1.3, all the TLS 3 proof machine that everyone's gone through valid, which is really nice because it means you don't have to reuse like all those papers that people did analyze the protocol. This is actually pretty straightforward for like the symbolic proofs. For the more detailed proofs like MeTLS is obviously harder. I think this first option, I think it's pretty clear it maintains the proofs because the proofs essentially no one cares about the encoding anyway. But the second one's more complicated. Just to give you a concrete example of what this looks like, here's an example of the client hello. So TLS client hello is like notoriously redundant. We have this legacy version which nobody uses. We have a session ID which is only there for interrupt purposes, and we have compression methods which are not allowed anymore. So there's a lot of redundancy here. There's also a fair amount of scope for reduction. Here's an example I was talking about with the length fields. You could have 65,000 bytes of cipher suites, which is roughly 32,000 cipher suites. I think people once thought you might want to have. So again, these encodings are really suboptimal in the sense that basically TLS they use the maximum width encoding for the old times. And so if you ever wanted more than 128 cipher suites, you then had to have 65,000 bits instead. That's really gross. So basically, you can cross off a lot of these things, and then you can also basically take everything that's super large and shorten it, and then you get a much more compressed representation, right? This is if you read the draft, like basically just the document does like all the kind of transformations everywhere you can. If you're like really going to be like super hyper aggressive, you can do this instead, which is basically say, well, the entire handshake shape is determined externally, and I'm just going to have wire encodings. So this, Scott, as you suggest, removes optionality. But if you're willing, depending on exact environment, science is good, science is bad. And so the key point here with the compression, I think Richard's going to make this point when he gets up, is like a sliding scale between basically having full generality and having maximum compression, depending on where you want to put the points.
Yeah, one of the things that you get out of the compression approach here, if you do expand to the full transcript and use the transcript as your inputs to like the key schedule, is that even if you do use some out-of-band negotiation thing to set which ciphers which you're using, you get the confirmation of those that the negotiation happened properly as a result of the key schedule over the expanded transcript. Sorry, Richard Barnes.
So anyway, I wouldn't say either of these. We have implementation of this compression approach. We have partial implementation of the other approach. The approach is more straightforward, so I'm quite convinced I can do it. Here's some preliminary results on like what you can get if you do this. These are, as you can see, you can get more aggressive at compression. This is like the sort of maximum dial on the first one. Other ones aren't quite as aggressive. Probably the biggest major contributor to the biggest sort of big chunk of potential reduction here after you after you be a little more aggressive is the finish messages, which are super large, and it's not clear how large they have to be if that exists at all, or if there's a way to sort of align them. So that's a still an open research issue. I guess, as I was saying, this is sort of like the first cut. There are a number of obvious places to remove it. The next steps for us are to like actually demonstrate that like this has isomorphism in 1.3, because the key point here, right, is to want to be a carrier of all the work that's been done in 1.3. If you can't do that, like it's not worth doing. And then I think we're trying to decide internally whether we like this compression strategy or not. It has some really obvious advantages in terms of being able to like really tighten the screws much harder. And in particular, depending on which profile you do, you just like can remove redundancy otherwise couldn't remove. And then this transcript issue comes up.
Yeah, just to emphasize the isomorphism point, like we have some empirical validation. There's isomorphism. The way we did the compression experimentation here is we took an existing TLS 1.3 stack and interposed compression layers. So at least that compression layer interoperates with itself, whether or not it's specified.
I mean, I think that one of the virtues or potentially non-virtues, depending how you think about it, of this is that it's possible to design essentially a gateway between a like CTLS stack and a TLS stack, where the gateway gets the traffic keys but does not get access to the endpoint keys. If you do the compression approach and you explore the transcript. So if you sort of take the first approach where you shorten the crypto, if you don't reconstruct the transcript, right, then the signatures don't work anymore, and so you have to have the keys for the gateway. But if you span the transcript on either side, then you can have a gateway, and you don't have to have the crypto key to the other side.
Hannes, in one of the earlier slides, you said that TLS is not compact, and I would like to clarify because I disagree.
Don't look at me. I didn't do that.
Because this group, and also, of course, the TLS working group has worked through the years, so numerous attempts to make different parts more compressed. And even the IoT groups have helped to do that. So actually, we are in a step-by-step, and the DTLS and TLS 1.3 is the latest incarnation of that.
Yeah. think a fair thing to say would be that, like, we spent some effort compactifying it, but most of that effort's been directed at the biggest things, like certificates, which are sort of very big in the web context. I think less efforts, but some efforts still been spent on compactifying the rest of it, but less.
So I have a clarifying question. Can you go back one slide?
Of course.
So I'm missing a column of what's TLS 1.3 like without either of these.
I'm sorry, I don't have one. Worse. Yeah, I mean, substantially worse. I mean, I would guess probably like 50% larger than the left-hand column, something like that.
I have a quick, what I think is a clarifying question. Jim Schott. If you start doing things like killing the finish message, do we really have any reason to believe that proofs are going to still stay in effect?
Yeah, that's probably the thing that I think is most sketchy. Cartha Bargavine suggested some angles that would let you maintain the proofs. But I think you actually have to convince yourself of that. That's probably the thing I'm like most resistant to pulling out. I strongly suspect you can shrink them quite a lot and not have a real problem.
Riyad, one quick question on the next slide. When you say demonstrate isomorphism, do you mean a mechanical proof?
Good question. And
it seems like it should be.
That would be ideal. I mean, I think so. So for the non-compression strategy, it's very straightforward. Because really, there's if you just look at the image, look at it and be like, look, these are the same thing. They're just everywhere I've had 2 to 32, I've written V instead. So that's pretty easy. For the compression thing, you have to demonstrate it. But I think mechanical proof would be ideal. Maybe Jonathan has one.
For the first strategy, then you can the proof is exactly the same. For the second strategy, there are known reductions that you can apply that mean your proof still applies. So I mean, you might have to do a bit of careful design, but it should be pretty easy.
And what we're hoping to have is basically a lemma, effectively, that you can then apply, that you can then basically bolt on to any proof, so that then when you go and you prove subserts, that you're just like, well, I applied this lemma, and now the whole thing carried through. That's what we're trying to get at.
Charter and then let the background over.
Yep.
Okay, so we're just going to pop up the charter, not
the proposed charter.
Proposed charter. So we're just going to pop up the proposed charter, and then the mic lines can fly. So essentially, this is, I think it was said earlier, but just to reiterate, this was the output essentially of a bunch of discussion with the sector specialist and a virtual interim. And where that landed so far is to have a bit of text at the beginning and to think about a working group that, there we go, narrowly focused, blah, 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 to look at requirements, document those, not produce an RFC for it, but just have them documented, and pick one, not two, not possibly zero, but a 0 or 1, AKs, and then be done. So at this point, I think we want to open the mic lines for whatever you want to talk about. Hannes.
If you scroll up a little bit, I think the focus on OSCORE alone feels a little bit restrictive for me, because today the way how people deploy IoT is using DLS and DTLS, and I could imagine the work that, for example, Eka presented with constraining that or making it slimmer would be perfectly fine for them without actually having to worry about OSCORE. In Göran's presentation, he sort of mixed the words between is in specifications, is implemented in this is deployed in somewhat creative ways, and OSCORE is not as widely deployed as you would like. So that's why I would like to have a broader focus, so it has a wider applicability to other environments, not just to OSCORE. And who knows what the next protocol is going to be.
So I think this discussion is actually two parallel discussions. So what is being done on TLS, making TLS more optimal, I think is excellent. We are really happy to use that for the things we have TLS, but it's not providing the most optimal solution for the most constrained settings. And that, I think, so there's actually two separate questions. One is, how do we solve the very constrained settings where we today are using OSCORE, where there is no key exchange protocol, and where we discussed this for 3 years? That's one question. Another question is, how do we make TLS in itself more optimal? And I think those are two good questions for the IETF, and they should not interfere with each other.
Hi, Phil Baker. So one of the things I saw on the list that kind of like concerned me was the statement, well, we're going to do this, but we're only going to look at existing key exchange protocols and not allow anything new. And then you have a new set of requirements. And, you know, there's two ways you can go about something like this. And the thing that I've seen working groups do repeatedly is they decide, okay, we're going to do something, we need to do it fast. So we're going to start from something that already exists. We're not going to look at anything new, whatever. And we're going to adapt it. And then they start with a set of new requirements. And then they go straight into a rat hole and it takes 3 times as long. So it looks to me like you are looking at a new key exchange rather than complete reuse. The other point I would make is looking at the 3 choices. The one that I would go to without looking at any of the technology is CTLS. And the reason for that is branding. There are implementations where I can, you know, if I want to use DTLS in a product, I can usually find it in a toolkit because the TLS folks say, oh, right, I've got TLS in my toolkit, I'll do DTLS. I will probably get CTLS as well for free. So if you want to actually make use of that, having a similar name is very useful. However, that would also apply if you called it E, F, or GTLS as well. so call it something TLS, whatever you're going to do.
What was the name Etsy used again?
This has been Keith. I'm going to jump in as area director and point out that we are in a BOF today. We are not in a working group. And so we have a RFC about what makes a successful BOF. And so you can be a successful BOF if you have agreement that there is a problem that needs solving and that this is the right place to solve it, that we have a group of people that are willing to work on the problem, that we understand what the scope of the problem is, and that we understand what the working group will work on. But we don't have to know what the solution is going to look like, and we don't have to work on it right here. So if we could try a little bit to think about sort of the higher level question, is this a problem that we want to solve in the IETF? And do we think we understand the problem? Given the length of the mic line, maybe having critical mass of participants is not going to be so hard. But let's try and focus on, do we understand the scope of the problem? We had some proposed requirements that we saw, maybe thinking about if that's in the right space. And, I know Bob came up to ask a completely different sort of requirement. That's a really good thing to be thinking about. At the high level, is this the right problem to be looking at? I think Phil maybe also made a similar sort of point. So that's the sort of points that are really good to be hearing about. I love that we have people thinking about the technology as well. If you could try to keep those to the minimum, that would be appreciated. And Benjamin.
Thank you. Benjamin Dam, Itron Incorporated. Some things I've heard that just aren't true, like, I don't want to kind of clarify, like IoT deployments today are using TLS. I've got 60 million gas, water, and electric meters that aren't using TLS at all. They're using proprietary security protocols that we think are kind of Sigma, but they're we can't do the proof work. If we had OSCORE and EdHoc 12 years ago, we sure would have used it. If I had EdHoc a year and a half ago, I definitely would have used it.
Just to clarify, you're not using TLS because it's too heavyweight?
There's a couple of different reasons, but yes, it all boils down to it's too heavyweight for various different reasons. Be happy to explain over beer or something. But really, I mean, for us, every bit on the wire, and there's no wire, it's just air, right? Every bit over the air costs money. So if the bigger the packets are, that's 20 more bytes to do a handshake, that costs us money. That's devices we can't talk to. That's more time in the air. That's more collisions in the air. So it really does impact. Like this kind of refining down and making the protocol do exactly what it needs to do. It matters to us. And also, I just want to say, like, if there's an isomorphism of CTLS to TLS, surely there could be an isomorphism of ad hoc to TLS, because after all, they are all sigma. So
It's a little bit more harder than that.
I concede that's probably not obvious. I'd love to see somebody try to do a construction.
Carsten Bormann. I really like what Hannes said, because COAP has a management and implement security scheme which is based on DTLS. So I would like to have a version of DTLS that is actually very good and not just good for what we are trying to do. Now, when you do something like this, you have to think about unintended consequences of the work. And I would instead like to talk about an intended consequence of this work, but that may still be surprising. Does anybody in this room think CTLS would have happened without this discussion?
No.
Okay, so this discussion is good because it might help me go get the CTLS version that I want to have alongside the ad hoc version that I also want to have for the OSCORE applications. So one of the intended consequences of actually chartering this work might be to keep a mild pressure up that we actually do want to have something like a CTLS image from the TLS working group as well. But obviously CTLS has a home already, which is the TLS working group. Ad hoc does not have a home. So what we're discussing today is how do we create a home for it? And that's, I think, a pretty important intended consequence as well.
Eric Scrolla. It's good to be at the back of the mic line. So I don't think that's what we're discussing. I've read this charter, and I'm pretty sure it's not what we're discussing, and may end up being what that resolution is, but that's not certainly, I don't see ad hoc written here as the destination target. Regarding the question, yeah. I mean, I'm generally positive about this charter. I have some nitpicks, which I'm happy to send to the list because I hate when people stand here and like go like that. Comma should be a semicolon. I think I do agree partly with what Hannes said and partly with what Joran said. Namely, I think like there are going to be people who want to do OSCORE, so there's better work with OSCORE. I think it would be sad if it only worked with OSCORE. I guess this sort of my basic premise here is that designing these things is hard and getting them right is hard. And so the more general applicability you can get and the more general value you can get, the better. And so obviously there's trade-offs here, but and obviously we have a set of requirements that are about performance. We have the requirements, but what I don't want to do is have a chart that narrows the scope so narrowly that we end up with something which is a single purpose thing which can't be used for anything else, because my experience has been you get a lot of proliferation. It's really hard to manage proliferation. I think, I was mentioning this for sure the other day, I was AD for Curdle and just like watching people try to add X25519 to like the vast menagerie of protocols we have. This is a nightmarish procedure. And so, so the more, I mean, like, let's remember the generality is not only the cost, it's also benefit. I don't think anything here says it can't have that, but I'm just going to say if people want to type that, it's going to do hard.
Colin James. I mean, I did not see, anytime we do a protocol, we have to trade off between making it more and more specialized for a narrow case and slightly more optimal and more generalized. And I don't feel there was enough data in any way to pick between those at this point. I'm perfectly happy with a charter that sort of has us go forward thinking about which one's appropriate, gives us more time to get the implementation experience on how that works. I understand you're going to say the charter doesn't say that, but it's clearly what's being discussed at this mic line. So on completely other comment, I just was shocked to find what an awful job the TLS working group has been doing on their protocol, and I hope they get it much smaller coming really soon.
So like I said, that doing this balance or trade-off between specialization and compactness is something that the working group should do. It's not something that you decide in a BOF or in the ISG when crafting the charter.
Hannes, I wanted to respond to the question of like, is there a problem? Is there a problem to be solved? And as you know, I work for a company who works on the embedded TLS stack and open source embedded TLS stack, and also deploys IoT devices. And we don't have these problems that some of the other people are reporting today. Like we can run secure IoT devices over those networks and other networks as well. And we do that today. And the primary reason is, of course, we can always cut down on things, but we try to look at the whole bigger picture. And the bigger picture is the whole lifetime of the device. What does it do at the beginning with onboarding? What does it do when it connects to the server? And what does it do afterwards, which is a very long time? And it turns out that Göran had this slide up, and he talked about 10 years lifetime from a battery, presumably a coin cell battery. And it turns out that many problems, like Heka mentioned with the large certificates, are actually elsewhere. Problems that are not as sexy, of course, for IETF participants to design around. That's, for example, the firmware update, where we have to cut down and come up with some really clever techniques to shrink it down, because that's where the battery then drains. Not because you run once in a while a key exchange protocol. And as mentioned earlier, we have already extended DLS to already right from the beginning to do session resumption and different incarnations of session resumption to actually shrink the things down. So you don't have to exchange all the certificates and the public keys, the Diffie-Hellman public keys all the time. And so that's why we don't see that those problems. And I'm happy to talk to you as well from ITOM, because I talked to one of your colleagues on where I see improvements in your design for the gas water metering devices. Having said that, since I've been working on making DLS better suitable for IoT devices to shrink them down, I'm happy to see the work that, like Cullen said, to cut down on DLS and DTLS. And I wish Göran and you and many other Ericsson colleagues would come along, or would have come along years ago, to come to the DLS working group to actually help out with some of the things, where I was always sitting alone and talking to 50 web people who care about totally different things, about quick and so on and so on. So, yeah.
Ivan Petrov. So in my company, we have developed a OSCORE implementation, and we are interested in LP1 networks, which are very constrained. For some of those guys, it's very important to have small implementations and the possibility to reuse some components that are already there for OSCORE. For this protocol, I think it's something that might be very helpful. And this is certainly some work that we'll be very interested in.
Malisha Vucinic. So, speaking probably on behalf of the Six-ish working group, I would just like to make some couple of clarifications. We are using OSCORE in an adopted working group document for since 3 years now. For 2 years ago, we asked at one meeting during the Prague meeting on the AIC for OSCORE. So for us, this boils really to designing an AIC for OSCORE, satisfying these requirements that Göran presented, and mainly supporting the transports that OSCORE supports while staying efficient. So I think it's good that we're having this discussion today and that we're having opposing solutions. But for us in Six-ish, this boils down to the requirement of the problem scope of designing an AIC for OSCORE.
Jarek Eriksson. So I think this work should go ahead, and I'd like to see OSCORE and the working group move forward, or and working group to move forward. And that that shouldn't preclude also work on TTLS or DTLS development. I really like to see that. And I just want to generalize my comment a little bit that, like, in general, we sometimes in the IETF we are very focused on transport layer security, and there are obviously specific security properties that provide. There are also some other situations where you actually need something else, and it's not a one-size-fits-all situation necessarily. That's probably part of the reason why we haven't always worked hundreds on updating TLS and so forth. But there are other things as well, and I think we're starting to see the effects of only focusing on one thing in the broader internet. We also have to look at end-to-end security in some cases across transport hubs and so forth. So that doesn't necessarily apply to this particular work, but more general. Thank you.
Thank them for, I'm doing minutes, so they let me hop ahead of them. Kathleen Moriarty, I'm also happy to see this for some of the same reasons that Yari brought up. I didn't know he was going to say them, but I'll echo the object level and that distinction is nice to have the combination of OS core with ad hoc potentially. So.
Michael Richardson. So I've implemented 6-dish Brewski over TTLS. And I could talk a lot about some of the interesting problems with threading models that happen with available libraries. Those are implementation issues. But one of the arguments for, as Philip said, about something TLS is that you get to download the standard libraries that people use everywhere, which means that you actually have the advantage of an existing system. The disadvantage is that you have to cope with the existing system. Okay, and you have to figure out whether or not I'm willing to, as Hannes's company has done, to rewrite it all from scratch, okay, or go with something else and figure out how to make it work. So one of the interesting things about the way that people implement CoAP servers is that they tend to process one request per thread in a thread pool, and this totally doesn't work as soon as you put a security context around it. Now, it probably doesn't work regardless of whether you put the security context above CoAP or below CoAP, just to be clear. But the current set of libraries that we have forces you to do it in a particular way. So that's something I just want to say, that in the space of CoAP-S, which is CoAP over DTLS, we have within that another layer of OS core once we get things going. Okay? Whereas what we're trying to do is actually key OS core. We don't actually want to run CoAP over DTLS. We want to key OS core and then just let CoAP run. Okay, and that's why we get the transport agility, okay, through other things and possibly through several layers. And I think that's something that's not captured in the charter. I don't have a specific suggestion, but I don't think that's captured in the charter. Okay, and I have CTLS. I would prefer that over in the CoAP EST spec. I would prefer that we just went with that, like tomorrow, make it CBORD, please, and let's just use that. That'll be great. But for the things that want to go through several devices and do things, I'm not sure that works, and I think we need something else, and so please, let's do this already.
Sorry to jump in. This is Ben Katie. I just wanted to clarify one point that Michael was making, because I'm not clear about it, and I think it's important. So you said that right now, in the stuff that you're implementing, you do DTLS, and you run CoAP-S over that, and within the CoAP-S, you're carrying OS core messages. Is that correct? And so what you would like to be doing instead is to not have the DTLS layer and to say we're going to run a lightweight AIK, and we're going to key OS core directly and just be sending OS core over the wire over CoAP without the CoAP-S, without the DTLS.
So the DTLS layer. Right, the DTLS record format.
Okay, so you're in fact seeking a goal where you're removing a layer from your entire encoding for the bulk data transfer.
Correct. Yes, that's exactly correct.
Justin Richer, and yeah, I'm definitely not picking sides here, but I just wanted. But I wanted to point out an observation as somebody who's really only been following this work from several hard distances away. And that's that I've heard a lot of people come up to the mic and say, oh, it's easy because we have this other similar thing that we've done, that if you just change everything about it, it'll totally be this new thing, and isn't that simple. And I think that's, I'm paraphrasing. But all I want to do is encourage the working group to approach such claims with the appropriate amount of skepticism, because if you're going to be altering existing systems in order to fit new use cases, you're going to be twisting them in ways that are really difficult to predict. And the details can really end up killing you there. So I just wanted to say that anybody who claims that, and I've heard this from multiple people with backing multiple different technologies going into this, make similar claims today, that if somebody is telling you, oh yeah, we just changed everything and it works fine on our little bespoke box, that's not going to scale as well as maybe you might think.
I would like to, this is Hannes, like to follow up on what Michael said previously. And it sounds like an easy thing to just re-implement these protocols and just do something else and create something new from scratch and then be done with it. The problem we ran into, and that's why we have a team of 10 plus people working more than 10 years on this, is because the embedded space is somewhat hard. There's lots of different hardware out there. There are lots of different operating systems, real-time operating systems. Some people run it bare metal. And then you have to integrate it into the IDEs as well to make the experience a little bit smoother. And that takes a lot of time. And I'm curious on who is essentially writing this new embedded security stack for ad hoc and maintain it for 10-something years, coming with all the feature that will come along, integration with hardware security and so on. I think people underestimate the effort. What looks like a hackathon project, a one-off thing, is actually much more work. And I was astonished myself when I saw it. It looks like implementing some of the extensions that come out of the DLS working group is so easy. But if you have to make it work over many, many different devices, it's difficult. It's not a joke. I'm not making this up. You look at our repository and how many contributors there are on how many hardware platform it runs. It's difficult.
Richard Barnes again. I just want to clarify a point that I heard a couple of people raise. This an idea that CTL this group could do its thing. CTLS could progress along the TLS working group. And I just wanted to say that I don't really think that CTLS actually makes sense as a TLS work item, because if you were going to design a compactified or compressed form of TLS, you have these questions of the trade-offs between rigidity and size that you want to negotiate. You want input from the community of IoT users to figure out where in that trade space you want to be. And I had a second point. Similarly, the structure of the compactification depends very much on the environment in which it's going to be used. I think if CTLS is going to be done, again, not saying that needs to be the outcome here, but if it's going to be done, I think it needs to be done in a context that has all the context we're talking about today, not just in the pure TLS context.
Dave Wheeler from Intel. I just want to reiterate something that I heard a couple people say is the presentation today and the work charter kind of seems like we're going to take something and just make a few tweaks to it to make it something completely different, and it's all going to be fine, and we don't even need an RFC, and we'll do this quick. And it kind of scares me. Maybe I misunderstand what's going on with the intended work, but it seems to me, from my perspective, is that we need a different keying protocol, and we should address that appropriately with the right amount of resources coming in.
Yes.
I get a little nervous about saying, oh, we're just going to change a little bit here with TLS and it'll be all fine.
So just to clarify, the point about the bit that's not an RFC would be just the requirements document. There's a history in the IETF of people writing requirements documents, and then everybody's so bored with them that by the time you get to try and turn it into an RFC, it just turns into a crap fest. So that it's the idea here, as stated in the draft charter, is to document and agree the requirements in a working group, but don't make that document an RFC. But the protocol itself, yes, would be processed as usual and become an RFC.
Okay, thanks. Just to clarify my earlier remarks, I was not suggesting doing this in TLS. This needs to be in a separate working group. And with all the will in the world, yes, we can try, hope to reuse proofs and so on. But at the end of the day, academics are more or less free. They've got infinite numbers of grad students to work on these things. And, if you want to do stuff that's going to require a grad student to write a whole bunch of proofs, that's not a bug.
Well, I'll have you know I'm not free. I'm very expensive.
It's very easy.
I think it actually, for TLS, I think it actually is the wrong solution to start making CTLS. I think the correct solution is to make static header compression rules for TLS, which is, way that you say that, okay, if the frame starts with, version number 3.0, we compress it by omitting completely. On the other hand, when we receive the frame, we see that, okay, we know that the first bytes are, version number 1.3, and we expand it there. And this way, we can always, compress the frame with the static header compression. If we ever need some extension or something like that, we can create a new static header compression rules for that extension or something like that. And this would allow complete, taking the existing 1.3 TLS frame, compressing it down with the static header compression, and sending it out with only minimal stuff that we need. And then in the other end, expand it back and pick up it. And then we don't modify the TLS at all. The only thing that we modify is this static header compression rules we need.
I'll be looking forward to your help with that. I actually just got up to disagree full slightly. The academics are not free. I think Carson maybe did the same thing. It was an enormous amount of work to get the people who did the proofs for us on TLS and on Quick. And like now that we're doing extensions, it's like actually quite difficult to get people to do proofs for us. So that isn't to say you can't get proofs for anything, but like it's like not like those guys work really hard to get and I don't want to trivialize that.
Just more, 2 points about TLS. First of all, I think that the work that will be CTLS at some point actually does need some of the resources of the people who are in the TLS working group, and it needs them more urgently than the resources that the constraint people bring in. We will have this wonderful requirements document at some point, and then they can just implement against that. But I think the hard things are actually touching TLS and doing this in a way that it doesn't break it. Now, I have a draft from 2013 that describes how to header compress DTLS. So that's not that hard. A student of mine wrote that, most of it. The problem, of course, is that the way TLS is defined, there are these wonderful finish messages, and they work on what was on the wire, and if you compress it, it's no longer the same thing. So you actually have to construct the entirety of the messages in memory before you are able to construct that finish message. So thinking about the finish message is probably the most important new thing I'm taking home from the discussion here. This is really a useful thing that I would like to understand better what we can do there in working with TLS.
This is Richard Barnes. Yeah, Carson, it's interesting you say that relative importance of the two sides of this relationship, because I think it's kind of like the things you're least familiar with seem the hardest. So like coming from a TLS background, the IoT bits of this seem harder to me. Something the TLS bits seem harder to you. I remember the second thing that we would need out of this community if you were going to do a protocol like this, which is, how does this AKE, what kind of integration surface does it need to expose to fit in with OSCORE, and how does that integration work? And I think that I just want to raise that as something, that would be good to get into this requirements document as kind of a description of the general shape of the protocol that needs to come out of this as well.
That's no more. Yes, there's also the whole application layer TLS usage issue that comes into that, and that we have to address at some point in time. The reason why I'm saying the IoT stuff is almost trivial compared to the security stuff is that, security must work. If you generate something that is 3 times larger than could possibly be done, that's not going to be a disaster. The security part that is going to be a disaster.
Yeah, Wabi. So it seems like from reading this and from the discussion today, there's an implicit shared notion of what all the costs are. And I think it's totally reasonable for everyone to say, well, bytes on the wire are extremely expensive, because indeed it's very expensive to send things over a wireless link. On the other hand, it may be the case that it would be useful to make explicit the supposed costs. So it may be that it would be useful to have multiple models. So the cost is this for this sort of thing. Because it might be that at the end, for example, you want to really crush the cost of crypto, and so it doesn't make any sense, as a very specific example, to use HKDF with a sponge hash. Maybe you could save a little bit of the work there. And I don't know, but it may be the case that some people in this room would really care about making that better. So it might be, as a next step, as part of number one, a useful thing to specify in some reasonable detail what the assumptions are about costs of various things. Because if the only thing you care about is saving bytes on the wire, then it seems totally reasonable to compress TLS and call life done. But it may be that that's not what you care about, and therefore that might not end up being the correct design.
Bytes on the wire are just easier to put together on paper. They're measuring power consumption. But someone previously mentioned ATLS, and I was wondering whether that's actually in scope for this group as well, because there's a separate document that Owen and Richard and I put together based on a Cisco, and we have products in that space. So it wasn't written with this specific goal in mind, but since it was brought up, I think it kind of makes sense.
Possibly.
Ben Kaduk, stopping back in to check by with the BAF questions.
We do have them on slides.
I'm really happy to hear the interest that people have and support for work in the space. I think the critical mass of people is pretty good on control. We're talking about the problem, which is good. I'm actually really excited to see the discussion about the scope of the problem. So we had several people come up and give some things that we might want to think about for the requirements document that were not mentioned in the slides. Like I was mentioning the number of AKEs we're actually going to do over the timescale of the device. How important that is for the battery life. How are we going to integrate with OSCORE that I think Richard was mentioning as a thing that the TLS experts would not be able to do. How generic, how specific do we need to be? How tightly coupled do the requirements that we come up with for a requirements document need to be with the use cases that we are currently looking at? How extensible or flexible do we want to be with the use cases? The immediately previous speaker, I think, was talking about what are the assumptions about costs that we're making. We probably want to write those down. Those are really great things. I'm really happy to hear those. So thank you to everybody for the good discussion. I'm going to step away from the mic. Hopefully we can keep going.
Okay, yeah, so a couple of things. Let's see if I can remember. Starting with this point on assumptions and costs. That's basically what we've been doing in the SecDispatch work with the benchmarks. And it turns out that this is not so easy to get all the costs exactly right. So you need to make assumptions, and in order to make a hard measurement about saying this is a good property, then you need to make assumptions, and those assumptions are based on something, assuming a certain deployment or radio technology or
see if we get any input.
So it's not. I don't think it's very easy to produce this excellent requirements document here, and I think that's good with the charter that says that it's not intended to be an RFC. It's intended to guide the solution. Then coming back to the solution space, what I think is important here to understand is that the optimal solution probably isn't CTLS, at least not in the most compact and aggressive as we've seen here. I mean, that's definitely not as lightweight as the protocol I was showing. So at some point, we need to make the choice. Are we going to do an isomorphy of TLS, or are we going to do an optimal solution? So that people are not sort of tricked to think that this will be both, because it won't be that, I'm afraid. At least as far as I mean, I think you've already done a lot of job in finding this isomorphy, and I have a hard time seeing that you will get down to levels where this is actually optimal. Sorry, I'm not saying that this won't happen, but as far as I can see. So the question is, what do we do then if we come to the point that is not optimal? Okay, I forgot the other things. I'll come back later.
Ben Kavek, so in light of what Jørgen just said, I think we do have some text in the draft charter is up on the screen about at most one lake. That is a draft text in charter. We can talk about that if that's the right thing to do. I don't know if it is or not.
Which actually, I mean, I have a question that hasn't come up so far, so I'm going to bring it up. We have a bunch of very smart people in the room. We have 2 possible candidate choices and a requirements discussion. In the IETF, that can turn into like 3 years of just squabbling. It's not clear to me how, and whether there's anything we could put in the charter that would help and would be great if there is. But how does that requirements discussion terminate to allow the second part of the work to continue is not clear to me. And if people have thoughts on that, I think it would be interesting.
Dave Taylor. I'm just commenting just on the questions that Ben's repeating a couple times. I think most of the questions, I'm convinced that the answer to most of the questions is yes. I think the most interesting part of the discussion is about the scope. Okay, and so, for example, if you just look at the text that's on the screen, all the text that's under program of work and even the text that's under goals is all just talking about constrained environments. It's not talking about either OSCORE or object level security. All the stuff in the problem statement is about OSCORE and object level security. And so the question is, are we solving the problem, or is the problem too narrowly described, or is the program of work too broad? And I think that's the question that Hannes was asking. And that's what I hear a bunch of people at the light talking about. So far, I've heard a bunch of support, and from what I've heard, for solving something with OSCORE. And if it can be used with other stuff too, that's great, right? But the current demand was OSCORE. That tells me that the problem statement is probably good enough, and maybe the program of work should be wordsmithed a little bit.
Oh, fantastic. Perfect segue, because I have the opposite interpretation of that, which is, which is I think that the program of work is roughly right, and the problem statement is a tiny bit too narrow. I don't have a problem solving the problem statement. I just think solving only the problem statement will lead to sadness. There we go.
This is Hannes. Adding another facet to this problem statement, and Kathleen mentioned it, that she would like to see something on object level security. And funny enough, OSCORE doesn't do object level security. In the ATLS document that I mentioned earlier, we described how to derive keys for COSI, which provides object level security. And I think that would also be very useful, because we have a number, like in SUD, we have a number of cases where we actually want to protect individual payloads, and we may also need a key management protocol for them. And I think that's good. Someone said earlier they wanted to add this or point out that OSCORE is protocol agnostic. And that's also only partially true. I think there's a little bit of over-advertisement here, because it's true when the stuff that comes in and the stuff that goes out actually is a REST protocol and has the same protocol semantics. And we talked about the iTron case previously. Your protocol you're probably using is not legacy protocol. It's probably not RESTful protocol. Most of the guys use MQTT, like Amazon, Google, Microsoft, not a RESTful protocol. Just to give you a sort of like an illustration of like how easy that fits into like this idea of being protocol agnostic.
David Bovek, Stephen's comment about competing protocols and taking forever reminds me of my experience. I am one of the chairs who survived the long-running TCP Inc. working group, which might have been what he had in mind. So let me offer one very concrete piece of advice. Based on what happened to TCP Inc., it would be irresponsible of the IESG to charter a working group here without picking the core protocol to start from.
Plus one.
Whatever it is.
So I see agreement and disagreement.
So in response to Hannes's comment, which is my asking IESG make tough decisions, no. I'm saying that when the charter comes out, tough decisions have to be made. I don't care by whom, I don't care by how, but they must be made. Though otherwise, those who fail to learn from history will be condemned repeatedly. And I pity the poor, and I have great sympathy for whoever gets stuck with chairing the resulting working group.
If the requirements aren't final, how can we ever decide between the options? One of them might not cover the requirements.
Alyssa Cooper, someone to ask you a question. How do you think that the point at which the decision is made will shorten the amount of time it takes to make the decision?
I am hoping that we can find a way not to spend 2 years debating a working group charter. There is a procedural limit to the number of BOFs you're allowed to have that ought to serve as a forcing function.
So your point being that this process will time out if there's no decision, and that's a better result than just charting a working group and having the process go for a long time and then making a decision.
I don't regard 2 years of a working group trying to make a decision that eventually doesn't get made in a timely fashion as a good use of the IETF's resources.
Carsten, I've been doing a lot of standardization in ISO. They use requirements a lot. And there's something called requirements engineering that you may not be aware of. Requirements engineering is engineering the requirements in such a way that your solution comes out as the one that is chosen. And so work on the requirements always is tainted by this problem. And we shouldn't be spending a lot of time honing these requirements, knowing that this is just energy that is dissipated from actually doing the work. Having some idea about the requirements is good, and I think we are kind of there, but this is not something that we should spend a lot of time.
So I think that by the time the requirements are finished, and that's something that we want the working group to do, either one of the proposals doesn't meet the requirements and then it's off the table anyway, or both meet the requirements and then we could decide by coin toss if there's no clear majority in the room for one or the other.
Colin Jennings, that's a really bad idea. I'm going to stop coming to the IETF if that's how we decide things. The
There is an RFC that says you can do it.
WebRTC group had a much more difficult decision about this, about a video codec to use. And there was no way, though I understand the pain of the TCP Inc. working group, for, I get David's point. We would never have managed to come to a decision on that topic had we not had roughly 4 years of repeated discussion about it in working group meetings. And we came to a solution that was pretty good. And I believe that we would have never chartered WebRTC if we decided we would have had to make that decision before we chartered the working group.
Yeah, it's long. So we're spending 4 years more to try to find some solution. Maybe we don't manage, and maybe a lot of applications are being used without forward secrecy, and we don't have a good key management protocol for OSCORE. I don't think that's a very good solution. We basically came to this room to try to find a solution for OSCORE. That's something that we can work on in parallel with optimizing TLS. I don't see that as, currently I don't see that they are the same solutions. They may be, but I have a difficulty seeing that at the moment. But I also don't see the problem having multiple solutions in this place. So that's one comment, and I forgot to say.
I just want to push back on the idea that picking one protocol is necessarily going to speed things up, because my experience is that when you come in and you start from a particular starting point and you say, we're going to pick this winner, but we've got all these other requirements, and so we're going to start changing it. It's like if you start off from the idea, well, we want a house, but we're going to remodel it. And then there is a certain point where it seems like the easiest thing to do is to start from a house and just remodel and, replace things. But, after I've replaced my roof, my walls, my foundation, and so on, I've actually rebuilt my house now twice. And, I've seen this happening in working groups. I've been in working groups where people have said in the chartering discussion, we have to have this done in a year, so there's no time to think about it. We must do it now. And 5 years later, they're still at it. And the working group has failed because they chose the wrong protocol to try and do it fast. So I don't think that it sounds like it's going to be a shortcut, but my experience is that it isn't.
So this meeting ends in 13 minutes. I don't think we're realistically going to run a beauty contest in 13 minutes. I guess I would focus on how we actually make forward progress. It seems to be that we can, there are a number of options. One is we could all go home. That's a possibility. One is we can schedule some other kind of meeting that is attempted to resolve the question of what the starting point is. It is not a working group meeting. And the third is one could actually, from the working group basis charter, the second two seem remarkably similar to me. I don't think is the point Melissa was making. As you can see, I'm deliberately avoiding the merits of this conversation, which I'm happy to engage them at some other point. I guess I'd like to focus on how we actually make some forward progress here.
That would be great. Benjamin Dan, Mitron. So yeah, seems like there's an audience problem that's happening, which is like HTTP is not CoAP isn't HTTP. I mean, why did we come up with CoAP when HTTP could do everything that CoAP does? And I would argue my position on that is that CoAP doesn't, like, CoAP and HTTP serve very different audiences. That the embedded audience does really have a lot of differences from the non-embedded audience. And if what you care about is streaming video, VPNs, and the privacy of your browser identity, then you're at odds with what embedded needs. So when do we, clearly that split happened with CoAP and HTTP. So when do we embrace that split with authenticated key exchange and the rest of the security primitives that we need? Just say, you know what, TLS serves a different audience. and you can't.
So Hannah's, we're going to just cut the mic line after Dave. So.
Dave Taylor, my comment is on the next slide, but after you're ready to cut the mic line. On the questions that you're going to ask, right? You're going to ask about do people understand the problem, and is there going to be a scope, right? I think what I've heard is that people do understand the problem, but there's two different problems. There's the narrow problem of OSCORE, and there's the wider problem that the milestones currently address. Okay, so when you ask your questions, if you can ask it in a way that doesn't presume that everybody has the same problem in mind, even though everybody has a well-defined problem.
What?
I'm going back to the discussion that Eric and I had at the mic. Last time I got up to the mic, I said the goals and milestones are much wider phrased than OSCORE. Okay, and so for some people here, the problem is the one that the milestones, as worded, address about HAE for constrained devices. Okay. A different set of people in this room are here for a more constrained problem, which is the one that the problem statement specifies in the charter, which is I need an AKE specifically for OSCORE. Okay. There's two different communities in this room that each have a well-defined problem and that they understand everybody's problem, but they have a different view of what the scope can be. So my question is, when you ask your questions on the next slide, if you can ask them in a way that helps me figure out how to answer the question. Because I don't know which questions you're asking as they are phrased in the generic sense, right? The way that they're phrased and how to have run successful BOF. You just copy the questions. It doesn't, if you just copy the phrasing, it doesn't accommodate. There's two different views of what the problem is, right? So I will sit down now, but that's my comment.
Okay, so
Is the mic Lights close,
yeah. So the way I see it, we're here because of the OSCORE problem. So any requirements, any solution that doesn't solve the OSCORE problem is not a solution here.
You should ask that as a question. Oh, I agree with that.
Okay. So this is okay. Yeah. So the question is, do you understand the issue? I mean, even if you think that the issue is bunk and we don't have to do anything, do you understand what the issue that's troubling people here is? So,
So I wonder to the degree we want to substitute the issue with the concrete text of the problem, as is defined in the chart.
Ask it both ways. I don't care.
Yeah.
We could just say the problem that OSCORE is facing.
So
No?
let's try this way.
Wrote the charter text there.
So
Let,
yeah, go ahead, Dave.
Stay on your slide with the questions. Okay. Do you understand the issues plural? Is when you say, is this a problem that needs solving? You can split that into two questions. Is OSCORE key exchange a problem that needs solving? And is generalized constrained scenario thing, which is a much larger problem, is that one that needs solving? Those are two different questions. Okay. When it says, is this a problem, implies there's only one problem. Here we're talking about two problems, the big problem and the little problem. Split into two questions.
I've got the PowerPoint thing.
The scope, right, broader and narrower, thank you. Broader versus narrower is a better way to phrase it. Thank you, Francesca. Friendly amendment accepted.
Is that, yeah? Go right ahead and ask that question. We don't have an editable version of the questions. Yeah.
We tried that. That killed the video.
So the last time we took this cable out, we had a 10-minute break. Okay, cool. 1 second. Where's the equal paths? No. Yes, thank you. Come on.
Some of us are getting old. Come on.
Yeah, it doesn't make it as big as it wants to be. It seems to be as big as it wants to be. Okay, so this is.
Now we can all.
Is this legible? We can read it out. Okay. Read it. You go ahead.
I can't.
You can't read it either from there even. Okay. Okay, so.
If it's like this, is that better?
All right, so we're going to ask these questions, possibly with more amendments as we go. But let's start with this. So if you think you understand the issues, please hum now if you understand the issues. If you do not understand the issues, please hum now.
So it looks like we understand the issues, plural.
Okay, let's go to the next question in here. So is OS core key exchange a problem that needs to be solved? Okay, that's the question. If you think OS core key exchange is not a problem that needs to be solved, please hum now. So I heard for the first question, a very strong hum and nothing, and for this question, a slightly weaker hum and nothing. So the next question is the broader constrained scenario a problem that needs solving? If you think that is a problem that needs solving, please hum now. If you think that is not a problem that needs solving, please hum now. So we had, I think, 2 people hum for that. Do you want to go to the mic and say why you think the broader problem is not a...
What's the point of having an anonymous hum?
Hi. Wait. Hi, my name is Phil Harum Baker. Having been through the space and implemented it and used lots of HANA's code, my experience is that if you have enough code space and network space and other power to run any TLS, those extra bytes don't matter. On the other hand, if you're really constrained, then it really does matter. So there's a kind of a step function where if you can run a little bit of TLS, then you probably can run a fair bit more. And Hannes's point to the fact that you don't do a lot of AKEs over the lifespan of the device is probably relatively true. And so I'm not sure that if you really want to run MQTT, thank you, I never always get it wrong. If you really are running that, the overhead of your security is probably not what's killing your network. It's probably other things. So in other words, you've kind of done a step point.
So we're at 3 minutes. We need to do a couple more things, but so
I would
very briefly
post a link to a paper that I recently wrote with Emmanuel on firmware updates, and there we do an analysis of different crypto libraries, and the issue with the code size is not the TLS stack, it's the crypto.
Yeah, thanks. And again, very briefly.
Right. So the question was, do we need this for OSCore? And the answer is yes, we do. And there are other ways to do a key exchange. You could use TLS to do that. You could roll your own. But the point is, there should be a way to do it in OSCore that doesn't require some external protocol.
Okay. So on that third hum, anyway, I think I heard a very big hum positively, and a few people who then happily came to the mic and gave us some negative reaction. So I think the other questions don't need edits. So is the IETF the right place to work on this? If you think it is, hum now. If you think the IETF is not the right place, hum now. Nothing. Thank you. Were you humming? Was that you humming?
I was going to say it sounds like IETF is the right place to start.
All right. So how many people are willing to contribute text, write code, be very active?
Can we split that question across OSCore and in general?
Sure. How many people, so in the context of OSCore, how many people are willing to contribute text and review documents and be otherwise active working with participants? And I guess, okay, so that's a bunch, thank you. In the context of not OSCore, In the context of not OSCOR, I guess that's the opposite. In the broader question, how many people? And now I'm curious. Thank you. That's fewer. And how many people put their hand up both times? That's for the ADs to figure out. Yeah. So there's some overlap, but there's also some a significant disjunction.
So I counted 15 to 17 for OSCOR. I counted 10 to 11 for the general case.
But 3 or 4 overlapping.
With 3 or 4 overlapping, confirmed. Yeah. So let's.
Okay, so in terms of the deliverables, this is the idea of working on the requirements, text, and then not turning it into an RFC, and then documenting a protocol. I think. Do you understand what the deliverables are? I think that's pretty clear, actually. Does anybody want to home that they don't understand the deliverables? No. Okay.
I didn't understand. So is this deliverables?
We're at -0 minutes.
Is it deliverables for both the scopes or for one of the scopes, or what is this question?
Yeah. Okay, so but I think essentially we're out of time, and I don't think we're going to get much information out of this. The ADs want to grab the mic for anything else? There's a mailing list. The discussion should continue there as well, and we'll talk to the ADs.
Big takeaway is it sounds like there's a scope conversation to have, but there's energy for an OSCOR, and there's interest in a broader thing, and we need to talk about what that means.
Yep.
So
okay.
Mailing list. Thank you, everyone.
These sheets are over there. So if you didn't sign the blue sheets, they're over here if you need them.